Hello, my dear J Warriors. Welcome aboard. This is your Captain Shreyas. And let's begin with the awesome, super duper case study questions along with assertion reasoning. Yes, the most important and as well as the confusing questions usually come from either of the two. Because, see, theory, either you know it or you don't know it. Problem solving, obviously, you need to develop those skills. But sometimes, even after developing the skills, even after knowing the concept, or even sometimes knowing the theory, may sometimes confuse you in assertion reason, as well as something might come surprising in your case studies. So let's do both of them, guys. I hope you guys are ready for this and you are all ready to rock and roll. Emperor, Trisha, Rafa, Sahana, welcome you guys. Nice to see all of you. Hello Kumar, hello Sasi, Wanakam. Good afternoon Shiva, good afternoon Jeffrey, awesome Shakti, hello, good afternoon. And by the way, let me tell you, I have scheduled the next session. Sorry for the delay. First of all, I had to keep you waiting. I hope you are studying and not yeah, wasted your time. Sorry, guys, for a little bit late. I'm going to conduct a session on numericals and graphs, okay, in the evening. Yes, that is what we are going to do. All right. Okay. So let me just turn off the volume. Okay. Thank you so much, guys. And I think I saw super chat somewhere. Thank you, Naveen, so much. Thank you, Naveen, our super duper fan, for sending your token of appreciation and love. Thank you, Naveen Prasant. Means a lot. All the very best for all of you guys. So let's begin with the class and with your Captain Shreyas. Okay. I hope you have smashed the like button and subscribe to the channel. Okay. For tomorrow morning, whatever I'm going to do, I'll let you know by today evening. Okay. So most likely it will be like a last minute revision, what I will do. So are you ready to wake up at 4:30, 5 o'clock in the morning tomorrow for like a quick revision, tuck, 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 to boost your confidence and to calm you down, to remove your nervousness. If you are ready, then Shreyas sir will wake up for all of you and he will come live for some time before your examination. Okay. We'll do that. Let's begin with the case study questions. Yes, we are starting with the case study based questions. Paragraph will be given, take a screenshot, and there will be questions on that. Okay, so here is the question number one. Check this out. Maxwell showed that the speed of an electromagnetic wave depends on the permeability and permittivity of the medium through which that light travels. Permeability is the magnetic property, permittivity is the electrical property. And the speed depends on both. And you can see that is given by this equation 1 by root. Permeability and permittivity is there both inside the root. So if this changes, the material property changes, the speed of the light in that medium will change. This fact led to Maxwell predict that light is a EM wave. The emergence of the speed of light from electromagnetic considerations is a very important achievement. Okay, the speed of electromagnetic wave in basically a medium whose permeability is mu and permittivity is E will be given by C by root K mu R, where K is the dielectric constant and mu R is the relative permeability. So if the medium changes, then there is a parameter called as the dielectric constant and relative permeability of the medium. So there is a factor which comes into play, because of which the speed of light in a different medium will give us a different value. Okay, so that is what it is. All right, so let's begin with the class and let's start with the questions. Please take up all your notes, and thank you, Santosh. Thank you so much for your token of appreciation and love too. Thank you so much. Yeah, you guys deserve a lot of likes, a lot of love, and a lot of support. Thank you so much, guys. It really means a lot. Thank you so much. Okay, so here is the first question. The dimensions of half epsilon naught E square. Epsilon naught is the permittivity and electric field is E. What do you think it is? Come on, the first answer, I want everybody spamming it, and then immediately go to the second question. You don't even need the paragraph for answering this question. You don't need the paragraph. Thank you, Santosh. I'm really happy to know this. Means a lot. Hopefully, we meet someday. Okay, so what do you think is the answer for this? First of all, this is nothing but the energy density. This is nothing but energy density. And energy density, as you all know, is going to be how many joules are there per unit volume. Volume is nothing but meter cube, and joules has the dimension m1 L2 T raised to minus 2, and this is meter cube, so that will be length raised to 3. So that will be m1 L raised to minus 1 T raised to minus 2. Is that right? M1 L raised to minus 1 T raised to minus 2. Many of you are saying option C. Is that so? Is that so? Think about it. Think about it. Is it option C or option B? I think it is option B, right? It is option B. Yes, be careful. It is energy density, not just energy. So many people think it is just energy, and that's why they mark a wrong answer. It is the density of energy. So energy per volume. This word density is very important. Per unit volume. Very good. Next, if if permittivity formula, mass is m, L is length, T is time, A is A, then what is the dimensional formula for permittivity? What is the dimensional formula for permittivity? How do you get dimensional formula for permittivity? There are many different ways of doing it. I think the easiest will be if you write this: force is 1 by 4 pi epsilon naught charge 1 charge 2 divided by distance square. So permittivity will be 1 by 4 pi is just a constant. Charge is nothing but current multiplied by time whole square. R square is there, and that force will come over here. Is that right? So when I try to find the dimension of permittivity, on the top I have ampere, okay, and that is raised to 2, time raised to 1 raised to 2, whole thing divided by R is in meters, so length raised to 2, of course, and force, which is mass into acceleration. Acceleration is meters per second square, so that is what it will be. Come on, mass will go on the top. I can say m is already raised to minus 1. M is already raised to minus 1. So many options will get eliminated, guys. Yes, come on. M is raised to minus 1. It goes on the top. Length, length, length will become cube, but it will go on the top. It will become L raised to minus 3. It will become L raised to minus 3. L raised to minus 3 is here also, here also. Well, what about time? What about time? This is T raised to minus 2. Goes on the top. It will become T raised to 2 and T raised to 2, which will become T raised to 4. Automatically, this option got eliminated. T raised to 4 is here. A raised to 2 is there over here. So I think it should be C for Capto. Yes, C for your Captain Shreyas. You can find me on Insta and Telegram on this particular handle. Correct. Yes, very good. Awesomeness. Kumar, Gokul. Yep. Awesome, awesome. Hanishri. Great, Sasi. Very good. Excelente, Elite. Excelente. Moving on to the next question. Electromagnetic wave of certain frequency will pass through vacuum in a medium with some permittivity. Then what is about wavelength that and frequency that you can talk? What is it that about wavelength and yes, frequency that you can talk? One thing is there that no matter where you go, in which medium, the frequency of the light never changes. Frequency never changes. In fact, it goes like this: speed of light, if it is f into lambda, frequency always remains the same. So if the speed reduces, the wavelength also reduces. So naturally, frequency should change, sorry, not change, but wavelength should change. So such things, wavelength and frequency both are unchanged. So this is obviously eliminated. Wavelength is doubled and frequency becomes half. This is eliminated. Wavelength is doubled and frequency remains unchanged. Okay, frequency remains unchanged. Frequency remains unchanged. But will wavelength decrease or wavelength increase? The moment you go into a medium, the speed has to reduce. If the speed has to reduce, the wavelength has to reduce. How can the wavelength increase? So C option is eliminated. 100% the wavelength should reduce. It should be option A. It should be option A. Do you understand why it is option A and not C? Because when you travel inside a medium, speed of light reduces. Speed of light is frequency into wavelength. Frequency does not change. Speed reduces, wavelength has to reduce. This is saying wavelength is doubling, wavelength is increasing. It can't be correct. Now you will be like, sir, how do you know wavelength is half? I don't even have to know whether wavelength is half. I know there is only one option where wavelength has decreased, so I will not be wasting my time and I will just mark option A. But if there were two options, one option said wavelength is half, another option says wavelength has become 1/4, then I have no other choice but to solve it. And the best way to solve it, yes, is checking what is the new speed. What is the new speed? In the paragraph, they had given the new speed formula is old speed by root k mu r. Root k mu r. That is the formula. C by root of k into mu r. Well, only the dielectric property has changed, whereas the relative permeability is still 1. So it will be C by 2. So speed has become half. Therefore, the wavelength will also become half of lambda. The wavelength will also become half of that wavelength. Yes, speed becomes half. So lambda will also become half. Hence, this is the correct answer. Is this absolutely clear? So that's what I have explained. How it is half, I have explained it right from here, because speed becomes half. So therefore, the wavelength also should become half. So therefore, I can say that the new wavelength will then be lambda by 2, because C has become C by 2. Electromagnetic waves travel through which speed in fluid medium, free space, solid medium, same speed in all media? 100% that is not correct. In the paragraph only they have mentioned they all travel in this particular speed only in free space. But the moment there is a medium, any medium, then you have to consider the permittivity and the permeability of that medium. So this is only going to be true in free space. Yes, 3 into 10 to the power 8 is only in free space. This is C option. No, it is not D. Okay, it is not D. It is not the same in all the mediums. Please understand that. Is that right? Okay, very good, very good. Awesomeness. Next, which of the following are not electromagnetic waves? Cosmic rays, gamma rays, beta rays, X rays. One of them is not an electromagnetic wave, is not. Which of the following is not an electromagnetic wave? It has to have electric field, magnetic fields oscillating in perpendicular directions, else it won't be an electromagnetic wave. Yes, gamma is definitely a highly energetic wave. X-rays definitely is an electromagnetic wave. Cosmic is. Beta is nothing but electrons. It is a particle. It is electrons. It is not electromagnetic. It is A option, guys. Many of you gave the wrong answer saying it is cosmic rays. No. If you see the electromagnetic spectrum, right? If you see the electromagnetic spectrum, where here the frequency increases, the energy also increases, the wavelength decreases. So if you see that order, then you will see that right after ultraviolet, you will get basically X-rays. You will get X-rays, short X-rays, long X-rays, and all of that. And then you will get gamma rays. Then you will get gamma rays, which is from nuclear reactions, and from distant stars. Cosmic is related to our outer space. Cosmic rays come over here. So this is the order of increasing frequency or decreasing wavelength. So all of them are basically electromagnetic waves, except for beta minus beta plus. They are electrons or positrons. Got it, everyone? Yeah, cosmic rays is an electromagnetic wave. It's just that you do not study about cosmic rays in detail or any such thing in your NCERT, but you should know it is an electromagnetic wave. Okay, you cannot say why cosmic rays is not the option. Cosmic rays is just a wave, but it's just that you do not study it properly. Got it? Okay. I hope this is absolutely clear. Please remember this electromagnetic wave spectrum. Okay, so solutions as it is. Question number 2 has come up on your screen. So there is only one page. After that, directly questions have started. So this is your second question, guys. I want everybody to focus on the passage. Take a screenshot, you might need it. Take a screenshot, you might need it. In the phenomena of emission of electrons from a metallic surface, when light of a certain frequency is falling on it, then emitted electrons are called photoelectrons, correct? Nearly all metals exhibit this effect with UV light, but alkali metals like lithium, sodium, potassium, cesium show this effect even with visible light. This is an instantaneous process, so they are emitted as soon as the light is falling onto that surface. The number of electrons is directly proportional to the intensity of the light which is falling onto it. Maximum energy is given by independent of the intensity of the light and depends only on the frequency of the light. For a given metal surface, a certain value of the frequency of light below which emission does not occur, that is basically your threshold frequency or threshold wavelength correspondingly. Okay, so this is your second question, case based. Right now, one question or one passage is done, one case study is done. I think I have kept some 6 to 7 or maybe 8 case studies, and because each question will have some 4 or 5 questions, and then we will do assertion reason based questions. Okay, so quickly smash the like button and subscribe to the channel, because today evening also there is numericals and graph based question practice which is going to happen on the channel. Okay, here is the graph which is given to you. In the photoelectric experiment, the graph is also plotted, C, B, and A. The question is which of them have same intensities, which of them have different intensities. Okay, come on, think about it carefully and let me know what the answer is for this particular thing. The graph is shown. Yep. Now remember, wherever that graph becomes constant, that is basically going to tell you the saturation current, and that saturation current saturation current is directly proportional to the intensity. Yes, it is directly proportional to the intensity. So the saturation current is same for C and B. That means B and C have the same current. B and C will have the same current because they have the same intensity. Is that right, everybody? Yes, same current and also same intensity. Okay, so B and C have equal intensities, B and C have different intensities, equal frequencies, B and C have different frequencies. I can only see one option there. B and C have equal intensities. This is a D option. I don't even have to check others, but still, for safety's sake, I'm doing it. What if the options were not arranged like this? What if there were more confusing options? Okay, now what about A and B? Well, this particular point over here is the stopping potential, and stopping potential Vs has this formula given by the energy of the incident photon is the work function plus E into Vs. So A and B have same stopping potential, same work function, same light. So this is the incident photon. So this is the incident photon. This is your work function, which depends on the metallic surface. So the same metal is there, but the light is also going to be the same. So A and B will also have the same frequencies, same frequency which is incident, same metal, and of course the same potential. So D option, definitely. Is that absolutely clear, my dear warriors? Shall we move ahead? Photoelectrons, come on, second and third, I want everybody to spam both the answers together. Photoelectrons are emitted when a zinc plate is heated, hammered, irradiated by ultraviolet light, subjected to high pressure and threshold frequency for sodium, whose wavelength threshold is 500 nanometers. What is the work function given by? All right. This session is going to be around 1 to 2 hours easily. Okay, because each case study only will take some 10 minutes easily. And plus we have assertion reason based questions as well, but it won't be 3 hours long. Okay, so what do you think about this? Yeah, this is 100% irradiated by your ultraviolet light. So things like zinc, etc., nearly all metals, see here they have mentioned metals exhibit this effect with ultraviolet light. It is there in the passage itself, you have to read it carefully. Yes, it's there in the passage itself. So 100% C option. Zinc is definitely a metal, so that is the reason for it. Threshold frequency Okay, sorry, wavelength is given. What is the work function? Work function is 1240 divided by 500. This is in nanometers. This will be in electron volt. This is the formula to find it out, because using hc by lambda is too old school, and converting it into electron volt is going to add unnecessary calculations. Just do the math and tell me, my dear students, how much is 124 divided by 50? 124 divided by 50. Come on, my dear students. Come on, my dear students. Yes, but that will be in electron volt. And if you see, all the answers over here are not in electron volt, rather they are in joules. So I have to multiply this with 1.6 into 10 to the power minus 19 to get it into joules. Come on, my dear students. Yes, how much is it coming out to be? Yes, how much is it coming out to be? Yep. How much is it coming out to be? Somebody saying 2.5, 2.48, 2.4. Okay. Yes. 2.4, 2.48 almost, and multiplied by 1.6. Check what is the answer that you are getting. 2.48, almost 2.5 into 1.6. That will be, I think, this 4 into 10 to the power minus 19 joule. This is one method. Second method of solving the same question will be, the work function is hc by lambda, where h is 6.6, 10 to the power minus 34, c is 3 into 10 to the power 8, and lambda is 500, but that is nano, so 10 to the power minus 9. Solve this, you will again get the answer 4 into 10 to the power minus 19 joule. This method involves you to remember this particular formula, where phi is 1240 standard number divided by lambda. This answer is always in electron volt, provided this lambda is in nanometers. So this entire answer is in electron volt if the answer of lambda is in nanometers. So this is a direct formula for electron volt, but again you have to convert it back. Yes, this electron volts E value you have to substitute to convert EV into joules. But if you don't want to do this, this answer you can find it using our traditional old school method also. Is that okay? No worries, Flair. You're not that late. You can still join in because you might have missed first case study. That's okay. You can watch that recording later on. Join in now, attend live, or else it will become a backlog. You don't have much time. Yes, the live is always better. Oops, solutions are there already here. Maximum, I should hide somewhere. Okay, the maximum kinetic energy of the photoelectrons emitted from the surface when the photons of energy 6 electron volt fall on it is 4 electron volt. What is the stopping potential? What is the stopping potential, my dear warriors? Yeah, come on, think about it and tell me. Think about it and tell me. The maximum energy of the electrons is 6 electron volt when photons are of 4 electron volt. What is the stopping potential? There is a direct formula. Yes, what is the direct formula? Stopping potential multiplied by E is maximum kinetic energy. That's it. Already this is given. The when photons of energy 6 electron volt fall on it, the maximum kinetic energy is 4 electron volt. So this is 4 electron volt. So this is E into Vs. E and E cancel. So stopping potential is basically 4, but obviously the answer will be in volts. So 4 volts is the answer, guys. Option B. Option B, of course. So you might ask, sir, what is this given for? This is chumma given to you. This is chumma given to you to confuse you. Chumma given to you to confuse you. Is that absolutely clear? Yes, very good. Next, the minimum energy required to remove an electron from the substance is called, what is that energy called? I think that is also there in the paragraph over here. The minimum energy required to take out that electron is basically your work function. Yes, you can see over here they have told that you need a light of minimum frequency, and below that you will not be able to pluck out that electron. Yes, that is called definitely as the work function. Yeah, that is the answer over here. Yep, very good. Awesomeness. So very straightforward question. Case study number 3. Case study number 3. Read this paragraph properly. Take a screenshot if you want to. Yes, take a screenshot if you want to. Okay. Come on, my dear students. What do you think is the answer for this? What do you think is the answer for this? Come on, let's find out. But first, read the paragraph. Okay. Electron is moving with some speed in a circle of radius r in a uniform field. Electron is able to travel circular path when the magnetic force is perpendicular to speed as well as the magnetic field. This force continuously deflects the particle sideways without changing the speed. Particle will go in a circle perpendicular to the field. The time required is basically t naught. Standard thing which you know about electron revolving around basically your in a magnetic field when a speed v is given to it. If the speed is doubled, radius will how many times? If the speed is doubled, the time required will become how many times? Very important question, guys. So come on, radius is nothing but mass into velocity divided by qb. That's one thing. So radius is directly proportional to velocity. So if velocity is doubled, even the radius should be doubled. That's very straightforward. So I think it should be option B. I think it should be option B. Just check this out, everyone. Everyone? Yes. Awesome. Awesome. Speed of the electron is doubled. The radius of the circle will become 2 times of r naught. Yes. Very good. Very good. Excellent. Excellent. Very good. Next. What is it? Speed is doubled. The time required will be how much? The time required is given by the formula 2 pi m divided by qb. 2 pi m divided by qb. It is basically independent. It is basically independent of the speed. So it will not change. So it will still remain as c. Yes, it will still remain as t naught. There will be no change at all. Is that absolutely clear? No, it is not anything else. It is not half. It is not a double. It is not 4 times. It is independent of the velocity. Keep that in mind. Yes. Very good. Many people make that mistake. Oh, the answers are given on the next slide. I don't want you to see that answers. Hold on, guys. Hold on. My God. Why the answers are given? One second. I'll just turn off the camera before showing you the next slide. Okay. Have a look at it. The given electron has a speed not perpendicular to B, then the trajectory is what? And the next question is the charge is moving parallel to the field, then the force acting is how much? Then the force acting is how much? Okay, come on. Answer both the questions. Yes, answer both the questions. Yes, come on, guys, think about it. The electron has been given a velocity which is not perpendicular to the magnetic field. So velocity is not perpendicular, it is at an angle. Then what happens is the electron basically goes in a path which is like this. This is basically a helical path, isn't it? Helical path. I hope you remember this. Yes, helical path. Yeah, so the answer is C. C for Capto, C for Captain Shreyas. Awesome, very good. Yugant, Sumay, very good. Sanjay, yes. Prajesh, awesome. Sarvanas, very good. Ajil, Gyanchand, great. If the electron is moving parallel, then what happens? If the electron is sent parallel to our magnetic field, then the force being Q into V cross B, this cross product will be 0 because they are parallel. So sine of 0 degree is 0. Sine of 0 degree is 0. So there will be no force and it will be D option. And then it will be D option. Yes. Then there will be no force, only acting on it. Yes. Very cool. Awesomeness. Very nice. Finally, you guys got the answer. Moving on to the next passage, the next case study coming up on your screen, guys. Read it carefully. When an insulator is placed in an external field, the dipoles become aligned. So you take an insulator like rubber, wood, glass, they are all insulators. You place it in some external field, the dipoles inside it will align in the direction of the field because there is a torque on it. And induced surface charges on the insulator establish a polarizing field in its interior. So as you can see, there is an external field from outside. The moment that external field comes, the dipoles they start arranging themselves. So this E naught has basically come from outside. So the dipoles start arranging themselves, because of which positive is collected on one side, negative is collected on one side. So you can think as if equivalent induced charges are there, and these induced charges then establish an internal field inside the medium to oppose the external field. This is the external field. This induced field will oppose that external field. And this EI is there inside the medium. It is established due to the polarizing nature of the molecules. The net field, obviously, the net field inside will be this minus this, because this field is this way. The interior field is opposing it. So the net field will reduce, and that is the reason why when you pass electric field through a dielectric medium, the electric field strength reduces some number of times. So the effect of aligning the dipoles in the insulator is called polarization, and the field EI is known as polarizing field because of the induced field, the polarizing nature. This is induced, so that internal field is called polarizing field. The dipole moment per unit volume of the dielectric is known as polarization. How much dipole moment? If you see, all of these are dipoles per unit volume. How much dipole moment is there is called as polarization. For linear isotropic dielectrics, that means standard mediums, the dipole moment is X multiplied by the net field, where X is called electrical susceptibility. Remember, in magnetism, there was magnetization is equal to magnetic susceptibility into B. Here it is electrical susceptibility into the net electric field. So they have made the same paragraph. Instead of magnetism, now they have made it for electricity. This part is already there in your NCERT, which talks about how dielectric mediums behave and how polarization occurs and how they oppose. So beautiful paragraph. I hope you have taken a screenshot of it. So expect such things. But I'll tell you, most of the times when you see some scary paragraphs, some new terms, don't get scared. Often, at least few questions you will be able to answer. All right. So let's see the questions coming up on your screen. Read the questions. 1, 2, 3, 4, 5. I will not read it for all of you. Just start solving all the 5 questions and we will solve it together, guys. Yes, we will solve it together at once. At once. All the questions are there. If you want, take a screenshot of this wherever needed and then start solving this. Which among the following is polar molecule? When air is replaced by dielectric medium, the maximum force of attraction between the charges separated by the distance, what will happen? Which of the following is actually a dielectric? For a polar molecule, which of the following is actually true? When comb is rubbed with dry hair, attracts pieces of paper. This is because of what? This is because of what? Come on. Okay. So what do you think it is? Which of the following is an example of polar molecule? O2, H2, N2. All of them look similar. They are odd man out. This is again the odd man out. If you compare it with the other three, this is because H is positive, Cl is negative. But on nitrogen, hydrogen, oxygen, what happens? The electron cloud is equally distributed. The positive and the negative centers coincide. So there is no such polarity. Like one hydrogen is not positive than the other hydrogen, or it is not more negative than the other hydrogen. Both are equally positive, equally negative. But in HCl molecule, the electron cloud is attracted towards the chlorine atom, because of which it will develop a negative delta charge, and hydrogen will develop a delta positive charge, which makes it a dipole. Small positive, small negative, separated by a distance. Hence, it has become now a polar molecule. Is that right? Okay. Very nice. Let's see what about the next one. When air is replaced by dielectric medium, the force, what will happen? Always the force will reduce k times. So force with the medium is force without anything which is in vacuum, whole thing divided by k. This is the standard result, guys. Yeah, the dielectric constant will reduce the field k times by factor of k. So that is the reason why the new force will decrease by k times. Yes, awesome, awesome, awesome. Which of the following is a dielectric? Basically a non-conductor. Dielectric means you should think of non-conductor. Non-conductor. Correct. It will be glass. It will be glass, everyone. Yep. Very good. Yeah. Everything else are metals. They are conductors. Definitely. For a polar molecule, which of the following statement is correct? Like this one. For example, H plus bond length negative, what happens to that electron cloud? Think about it, my dear warriors. Yes, the electron cloud has shifted over here. The electron cloud has shifted over here, because of which the positivity has come over here and the positiveness is hardly there over here. So the positive and the negative values are separated. The center of gravity of electrons and protons do not, yes, center of gravity, where the center of the electrons and protons, they do not coincide, I believe. Is that right? So this should be B option. Is that right, everybody? B option. Very good. Centers do not coincide of positivity and negativity. When you take a comb and rub it with dry hair, then it attracts bits and pieces of paper. Come on, why? This is because, come on, think about it. Comb polarizes the piece of paper. Comb induces a dipole moment. What do you think? Yep. What do you think? Comb is rubbed with dry hair, attracts bits of pieces of paper, because when you rub it with dry hair, yep, because of that rubbing action, the charges are developed on the comb, and then the comb, which is charged, then acts like an external agent to the paper. That electric field, when passes through the paper, it polarizes the molecules of paper. So because of which attraction is developed. So it ends up polarizing the molecules of the paper. The comb acts like an external field. So the comb, which is charged, it acts like it gives the external field, I will say. It will give the external field. And when that external field passes through the paper, which in this case is our medium, that medium is now going to have a lot of dipoles. These dipoles are nothing but induced dipoles. They are induced dipoles, hence they get polarized. Hence the answer will be A. Very good. Awesomeness. So I will give you one more question. Yeah, answers are there on the next slide, but that's okay. Let's see if you guys can solve the sixth question. Let's see if you can solve the sixth question. If there is a solid, if there is a solid of, if there is a solid of, of, let's say mass, sorry, of side length is equal to 2 meter in a cubical form, having 4 moles of molecules, each having a dipole moment, given by 2 into 10 to the power minus 8 coulomb meter, then find the net field, find the net electric field if net electric field and polarization, both polarization, if electrical susceptibility is 10, if electrical susceptibility is 10. This is the question. Okay, let's try to solve this. There is a cube whose side length is given to us, and it is made up of small dipoles, dipoles in it, dipoles in it, and each dipole moment is given, and it has 4 moles of molecules. Question is, find the net electric field and also the polarization if the electric susceptibility is 10. So from this, one thing is clear, we can find polarization by this particular formula. Remember, polarization P is given as the dipole moment per unit volume. Dipole moment per unit volume. Okay, so what I can do, I can just say polarization. Polarization P is nothing but the total dipole moment, total dipole the total dipole moment divided by the volume of it, divided by the volume of it. Now there are so many molecules, each having this much dipole moment. So you multiply it by the number of molecules, number of number of molecules multiplied by the dipole moment of each molecule, dipole moment of each molecule, whole thing divided by the volume. Volume is nothing but the side cube because it's a cubical box. So sides cube. What is the number of molecules? It is the number of moles into Avogadro number, which is 6 into 10 to the power 23. Do you guys agree with this? So this is the total number of molecules, which is number of moles into Avogadro's number. Each dipole moment is given by 2 into 10 to the power minus 8. So that is that. And side length is 2. So this is going to be 2 cube. Now you can see 2 cancels, 2 raised to 2 is 4. That also cancels, only 6 will be remaining. So it will be 6, 23, and you have minus 8 over here. So that will be 6 into 10 to the power 5. 6 into 10 to the power 5. That is what you are going to get it as. Yes, 6 into 10 to the power 5. Everybody with me? Sorry, 15, my bad. Why am I saying 5? 6 into 10 to the power 15. What will be the unit? Well, you can see over here, this is moles, forget it. This is nothing but coulomb meter. Down, you have meter cube. Down, you have meter cube. Meter cancels, so it will be coulomb per meter square. So it will be nothing but coulomb per meter square. Everybody with me? So that is your polarization, which was asked. So that job is done. Now, next thing is to find the net field. So for that, can you see there is a formula given, net field multiplied by susceptibility, electrical susceptibility is our polarization, So in the next step, that is what I'm going to do, my dear students. So the polarization is susceptibility into your field. So our field will be polarization by susceptibility. Polarization, we just found it as 6 into 10 to the power 15, and susceptibility is given as 10. This is nothing but your electrical susceptibility. So that's it. That is going to be 6 into 10 to the power 14. 6 into 10 to the power 14. Usually this is in volts per meter, or you can also use Newton per coulomb. That's it. That is the answer for it. Is that absolutely clear? Yeah, very good. Awesome. Yes, we can use that flare. P by E. Exactly. That's what I have done. Yes, susceptibility is nothing but P by E, which was also given right over here. Which was also given right over here. Yeah, just use that. So you can get numerical based question also. No, dipole moment is not in centimeter. It is coulomb meter. Don't get confused. It is not centimeter. Okay, it is not centimeter, it is coulomb into meter, charge into length, right? So this is C capital, don't get confused. It is not cm, C small m. No, it is capital C, small m. So if you are getting confused, better write it like this, capital C m. So then you cannot be confused. Okay, so that is the unit, coulomb meter. You can put a dot also. So that is going to be, yeah, not misleading then. Okay, so that was that question. So here we come up with the next passage, next case study. The EMF which is introduced across the ends of that conductor due to the motion in a magnetic field is called motional EMF, and it produced due to the magnetic Lorentz force acting on the electrons of the conductor. So whenever you move a conductor inside a magnetic field, QV cross B, which is also called as your Lorentz force, acts on it. So the free electrons, they are only allowed to move. They settle down on one side, leaving the nucleus positively charged. So that develops a potential difference, and hence that potential difference acts like an EMF when you connect that conductor to an external circuit. Okay. So for a circuit shown, if the length is L moving with speed V perpendicular magnetic field B, then all the induced parameters uh, then all the induced parameters are possible in the circuit and the EMF is BLV. Okay, so let's solve this particular question. Oh, yes, it is the Fleming's left hand rule. Yes, it is the Fleming's left hand rule. Everybody with me on this? Yep, awesome. Conducting rod is moving, then the current in the rod is how much? Well, EMF will be BLV. This will be EMF. EMF by your resistance, what will that be? By your resistance. Exactly, that will be your current. That will be your current. So I think it is option A directly. Yep, everyone. Awesome, awesome, awesome. Very good. Next, if this much rod carrying this much current, then the mechanical power required to move the rod with this much speed will be how much? What is the power required? They are asking. Okay, let me just create a duplicate of this. Okay, let me try to solve it over here. Oops. Yeah. Okay, see guys, power will be voltage into current. You can write voltage into current. Voltage we already know is BLV, and current we have just figured it out. It is BLV divided by resistance. So it will be B square L square V square divided by R. So now you just have to substitute everything. Magnetic field is 1.25 millitesla. So 10 to the power minus 3, the whole thing is square. Multiplied by the length. The length of the conductor is 0.1 meter. So 0.1 square. Then the next thing is velocity. Velocity is 1 meter per second. So 1 again the square. Whole thing divided by the resistance. Oh, I don't think we need the resistance because they have already told the current is this much. Okay, so this was unnecessary then. I'm so sorry, guys. Yeah, the resistance was not given. Instead, the current was already given. So what I can then directly do, is then say power is equal to EMF into current. EMF is BLV, and then this is current. Magnetic field is 1.25 millitesla. Length is 0.1 meter, velocity is 1 meter per second, current is nothing but 50 amperes. Current is nothing but 50 amperes. So you just have 1.25 into 5 that you have to multiply. Come on, multiply 1.25 multiplied by 5. Yes, 125 into 4 is 500. So this will be 625. So it will be 6.25. This 0.1 and 0 cancels. So will it be 6.25 into 10 to the power minus 3 joules? Just check it out. 6.25 into 10 to the power minus 3 joules. So that is joules per second. Sorry, joules per second. So this is option C because this is 6.25 milliwatt. Joules per second is nothing but watts. So 6.25. Just check it out. Option C. Excellent. Very good. Option C. Everybody got it? Well, let's move to the next set of questions. So this was done. What about this? This much voltage at this much speed. This much speed, how much voltage? Direct relationship. EMF is BLV. So it is directly proportional to velocity. So E2 by E1 is V2 by V1. So second time, what is the EMF? We have to find. First time the EMF was 1.5. The new speed was 10. The old speed was 15. So you can clearly see that E2 will be 1.5 multiplied by 10 divided by 15, which will just make it 1 volt. Where is 1 volt? Option number D, of course. Option number D. Everybody getting option number D? Yep. Sir, induced current, then B for the first question. The direction of the induced current is basically Fleming's rule. That's it, left hand rule. No, no, no. It is not the right hand rule. This is option A. Yeah. Okay. It is, yes, it is the Fleming's left hand rule only. I think the answer has been also put over here. See, this is your left hand, the magnetic field, the current, and the motion. The motion is given. So which direction will that current be introduced? That is given by your Fleming's left hand rule. That right hand rule is used in your magnetic effects of current, where you have to find the force acting on a current carrying wire. You are getting confused between the two. That is different. ILB formula. That is your Fleming right hand rule. Getting my point? Yeah, don't get confused. Next, what is the dimensional formula of EMF in MK system? Okay, how do you find the dimensional formula of EMF? So guys, can I do this? EMF is measured in volts, and volts is how much joule of work you do per coulomb, and joule is nothing but force multiplied by displacement, and coulomb is nothing but current multiplied by time. Current multiplied by time, that's it. So force will have the unit of m raised to 1, l raised to 1, t raised to minus 2. Displacement is l raised to 1. Current is a raised to 1. Time is basically t. So what will this become, guys? M raised to 1 is there. L raised to 2 will be there. T raised to minus 3 will be there. A raised to minus 1 will be there. M1, L2, T raised to minus 3 and A raised to minus 1. Come on. Is it there somewhere? I think it is there. Where is it there? Yes, option A. Very good. Option A. Yes, option number A. Can you see that? Yes, option number A. So where did we do it? Just now over here. So volts is how much joule of work you do per coulomb. Force is multiplied by displacement, you get work which is measured in joules. Coulomb is current multiplied by time. So now you know the dimensions of force, displacement, current and time. So ampere goes on the top, time raised to 1 goes on the top as minus 1, multiplied with minus 2 becomes minus 3, L1, and this L1 will become L raised to 2, M raised to 1 stays there as it is. Is this clear? Is this absolutely clear? What do you mean by why not right hand rule? Rotate opposite. I'm so sorry. You are right. Yes. Left was for this and right was for that. I'm so sorry. Yep, you're right. Sorry, guys. This was Fleming's right hand rule. I'm so sorry. Left hand rule was for the force. Right hand rule was for the EMF generated. I'm so sorry. I'll just correct myself over here. Yeah. So I'll just probably write it over here. Where can I write it? Over here. Okay. So see guys, remember that formula is there. Force is equal to ILB. So to find the force on a current carrying wire, we will use the left hand rule. We'll use the left hand rule. And when you have to use EMF is equal to BLV and the current will be BLV by R. In order to find the direction of the current, here we use our right hand rule. Here we use our right hand rule. Okay. Yes. So sorry, correcting it over here right away right now. Yes. Yeah. Great. Great. Thank you so much for pointing it out. Yeah. Great. Usually, whenever we do it in JEE, we do not remember those Fleming rules. If you remember, what we do is a very interesting thing. In order to find either the force or to find the direction of the EMF, we directly use the cross product. We don't have to remember which of my finger is I, which of the finger is L, which of the finger is force, or which hand do I have to use. I directly stick I, L cross B, and if I have to find the EMF, then I use, yes, L dot producted with V cross B. So this is a much better way of finding the answer rather than using the left hand and the right hand rule. So here what happens, whatever is the direction of V cross B, is what is going to give me the EMF, and here whatever is the direction of L cross B will directly give me what is the direction of the force. So every time I basically use the cross product to find the direction. So this method is much better, especially for your competitive exams. Yeah. Okay. I hope this is very, very clear. Yes. Is that understood? Everybody with me on this? All right. Moving on to the next question coming up. and here it is. Okay, this is question 6, case study 6, case study 6. An experimental setup to measure or to verify photoelectric effect is shown. The voltage across the electrodes is shown, okay, with an ideal voltmeter, okay, and you are changing things by moving jockey. There is a jockey over here, that is the contact point. This is your potentiometer wire, okay. The battery used is of 16 volts and internal resistance is 2 ohm. So this part is of potentiometer circuit. Now immediately you will be like, sir, potentiometer is deleted. Let me tell you, maybe the questions may not even involve the concept of potentiometer. This is what happened in JEE also. Just because a word was used, just because a word was used of potentiometer, students thought it was out of syllabus. See, if that word is used, but it is not actually used in any of the formulas, then it is not out of syllabus. So don't get scared by it. Okay, the resistance of the wire, the resistance of this wire is 8 ohms and 1 meter in length. Okay, all these things are given to me. Okay, this one is your photoelectric setup as it is. Then what else they tell? The photo current is measured with the help of an ammeter. The potassium oxide area is 50, separation is 0.5 millimeter in the vacuum tube. So basically, this particular area and the material is given to me. It is of potassium oxide, area is given, separation is 0.5 millimeter. Photo current is very small, so we can treat the potentiometer circuit as independent circuit. That means this circuit is different from this circuit. Ignore any relationships between them. Ignore any relationships between them. That is what they have told. Okay, the wavelength of different colors of light they have given, and read the passage and answer the following questions. Now, the moment you look at this question, 100% you will have very, very scary thoughts, but let me tell you, it is not that difficult. Flare, gamer, like I said right now over here, like I said, when you have to find the force on a current carrying wire, left hand rule. When you have to find the current due to motional EMF, then your right hand rule. So left hand rule, when you have to find the force on current wire, the force ILB formula. Here right hand rule, whenever you have to find the motional EMF, whenever you have to solve the motional EMF questions, which is EMI chapter. This is magnetic effects of current chapter. Okay, is that absolutely clear? All right. So have you taken the screenshot of this and this? Have you done that? Yeah. Have you done that? Okay. No, it is not deleted. It is not deleted. Who said it is deleted? Who said this is deleted? What are you guys saying? Just because the word is there of potentiometer, you will say that it is deleted. Yes, it is deleted. But for this question, you cannot say, sir, it is deleted, I will not solve. No, you cannot say that. You cannot say that because maybe the questions are not even going to use the concept of potentiometer. So don't think that it is deleted just because you see a word. That's what I'm trying to tell you. Okay, question 1, question number 2. Here it is. When radiation falls on the cathode plate, a current of 2 microampere is recorded in the ammeter. Assuming that the vacuum tube setup follows Ohm's law, then what is the equivalent resistance of the vacuum tube operating in the case when the jockey is at end P? Read it again. Light is falling on the cathode. Current is this much. The ammeter in the ammeter. Assuming that the tube follows Ohm's law, then what is the resistance of the tube operating in the case? Okay, let me go back to that particular tube. Okay, the current is basically 2 microampere. The current is basically 2 microampere. Now think and solve. Now think and solve. The current is basically 2 microampere. Assume Ohm's law is valid. Assume Ohm's law is valid, and assume that the jockey, assume that that particular jockey is at the end P. Okay, so this particular jockey is not over here, rather it is given to be over here. But remember, we have to forget that this circuit is related to this circuit. They are both independent. There is no relationship between them. Now just solve it normally like your Ohm's law, like your resistors, current, voltage. That's all. That's what they are saying. Just solve it normally. clearly, there is some voltage across these 2 points. Clearly, there is some voltage across these 2 points, which is measured by the voltmeter. If you can tell me the voltage, then 100% you can tell me what is the equivalent resistance. You have to find what is the equivalent resistance of that particular tube. To find that out, to find that equivalent resistance of that tube, it will be the reading of the voltmeter by the reading of the ammeter, because R is V by I. Voltage, I do not know. Current is basically 2 micro, which is 2 into 10 to the power minus 6. Can you guys quickly think and tell me what reading will the voltmeter show? What reading will that particular voltmeter show? Come on, my dear students. Come on, my dear students. See, some things are given. The battery used in the potentiometer circuit is of 16 volts. Internal resistance is 2 ohms. The resistance of 100 centimeter long potentiometer wire is 8 ohms. That is also given to me. And they are also telling, the operating case when the jockey is at end P, assume Ohm's law is valid. Find the resistance. You just need the voltmeter reading, guys. This circuit and this circuit, they are independent. How much will be the voltage across these 2 points? Just think logically. Just think logically, you will get the answer, guys. Yep. This much resistance is 8 ohms. Okay, this much resistance is 8 ohms. This is 16 volts, and there is 2 ohms over here. So what is the voltage between these 2 points? What is the voltage between these 2 points? So that is the voltmeter reading. That will be current flowing in this circuit multiplied by the resistance, which is 8 ohms. Current multiplied by the resistance. What is the current? It is the total voltage divided by the total resistance, which is 8 plus 2, which is 16 by 10, which is 1.6, which is 1.6. Is that clear, my dear students? Is that clear, my dear students? So that is, yeah, 18 by 2. Oh, sorry, I forgot to multiply it by 8. My bad. So multiplied by 8. So that will be 16 multiplied by 8 divided by 10. Yes. So that is 1.6 multiplied by 8. 1.6 multiplied by 8. 16 8s are. Yes, come on. 16 8s are. Everyone. How much? 128. 128. Very good. So it will be 12.8. 12.8 volts. Now this reading is shown by the voltmeter. So you are going to put 12.8 volts over here. That's it. Divide it with 2. Divide it with 2, my dear students. How much is that resistance going to be? How much is that resistance going to be? Yes, 128 divided by 2 is 64. So 12.8 divided by 2 is 6.4. And this will be into 10 to the power 6 ohms. So this will be 6.4 mega ohm. So that is the resistance. Is that absolutely clear? Potentiometer is deleted, but there is no concept of potentiometer which is used in this problem. So guys, you cannot say that this is out of syllabus. Even in JEE, NTA, when they gave the question, they did not accept it as bonus. So do you think CBSE will take it as bonus? Obviously not. Think about it. The people involved are the same. They will not take it as bonus, and case study has the authority to push the syllabus even beyond your prescribed syllabus. You cannot argue in any court saying that this is out of syllabus. Not possible. Yeah. So in order to measure the voltage, can you see what I have done? In order to measure the voltage between this point and this point, what have I done? In order to measure the voltage between this point and this point, I am measuring the voltage between this point and this point, between this point and this particular point. So whatever is the voltmeter reading here will be the voltage over here. This itself is like a big resistor of 8 ohms, So to find that voltage, just consider this part of the circuit which I have shown, 8 ohms internal and the battery. So to measure this voltage, I will just have to find how much current is flowing in this part multiplied by the resistance. Ohm's law I have used. Remember, they have told Ohm's law is valid. So current into resistance. Current is voltage by the total resistance. Voltage by the total resistance, 8 plus 2. So multiply by that 8 number. So that will give me 12.8 volts. So the voltage over here is 12.8, which is the same over here, which is the voltage reading here. From that, I can find the current over, or rather, from the current and the voltage, I can find the resistance over here. Is this now absolutely clear? Flair and everyone? Sahiti, is this clear now? Everybody? Everybody? Cool? Let me know, guys, quickly in the chat box. Is this now clear? Flair, don't spam, because the admin will be looking, and if they see some spamming happening, they will block. Yeah. Let me know, guys. Okay. Great. Now, the next part of the question. Next part of the question. It says, it is found that the ammeter current remains the same even when the jockey is moved from one side to the middle point. Okay. So, again, see, the knowledge of potentiometer is not required only. Knowledge of potentiometer is not at all required only. Okay. Great. Now, next thing, assuming that the incident photons eject electrons and the power of the light incident is this much watt, then what is the color of the light? My God, something led to something. What is the color? That means we have to find the wavelength, because if you remember, there is a table given of what is the wavelength and what is the color. What is the wavelength and what is the color? So somehow I have to find the wavelength, the power is given, the current is given. How are they exactly related to each other? So here is my logic to solve that particular question. Or maybe I can do it here only. No, there is not much space. Okay. So the power is given to be how much? 4 into 10 to the power minus 6. 4 into 10 to the power minus 6 watts. The current is still 2 into 10 to the power minus 6 ampere. The current is still this much ampere. The power is still this much. And they are asking me the color. That means they are asking me how much is lambda. Now you should start wondering, how are these even related to each other? How are these even they related to each other? Well, here is the logic. Power is nothing but the total energy, the total energy per unit time. Isn't it total energy which is falling per unit time? Now, current is given, lambda is asked, power is given. Come on, guys, think about it. Is total energy somehow, can we calculate it? I think so. I'll tell you how. Total energy is basically number of photons multiplied by energy of each photon, the whole thing divided by the time. Oh, interesting. So now that I have got this, what is this number of photons, per unit time exactly equal to? Because energy of a photon, we know it is hc by lambda. Somehow I've got lambda over here. What is this exactly number equal to? Whatever photons fall, they will emit electrons. So this will be also number of electrons per unit time. Number of electrons per unit time. This is into hc by lambda. What is the number of electrons per unit time? Think about it. Number of electrons per unit time. Well, I'll give you a hint. If you talk about current, current is number of electrons per unit time into the charge. This is the formula, guys. Current is the total charge per unit time. Total charge is N into E. This is divided by time. So number of electrons per unit time. From here, you can see it is nothing but the current divided by the electron charge. That is what it will be equal to, the power, and this into hc by lambda. So therefore, lambda will be current into h into c divided by E into P. Therefore, lambda will be current. Current is 2 into 10 to the power minus 6. H is 6.6, 10 to the power minus 34. C is 3 into 10 to the power 8. E is 1.6, 10 to the power minus 19. Power is 4 into 10 to the power minus 6. Just check this out. How much is the value of lambda you are getting? Just check it out. What is the value of lambda that you are getting? Yeah, current is not E by T, it is NE by T. Be careful. Current is nothing but the total charge per unit time. So think like this. It is the total charge per unit time. Total charge is N into E by time. So therefore, N by T was actually I by E. That is what the logic is. So number of electrons per unit time was current by E. Okay. Now what is the value that you are getting? What is the value that you are getting, my dear students? Just tell me quickly in the chat box. How many meters that you are getting? Somebody is saying 9.9. Yeah. Is that so? Just check it out, guys. I will also try it out. Okay, I'll do one thing. I'll use my phone or calculator. Wait. I'll do one thing. I'll use a calculator you don't use. Okay, I'm just trying it out. 2 multiplied by 6.6. 2 multiplied by 6.6 multiplied by 3 divided by 1.6, 4, 6.18 is coming, 6.18, 6.187. Potentiometer is deleted, Varun, but they can involve potentiometer as a context in the question without actually using the knowledge of potentiometer. So as long as the knowledge of potentiometer is not needed, it is perfectly fine. And you can see in the entire question, we have never used what is the potentiometer, what is the theory of potentiometer, we have not used. We have just used Ohm's law, photoelectric effect, photons concept, that's all. So even though potentiometer is deleted, it doesn't matter. Yeah, 6.187, okay, into what? Into what? 6, oops, 6.187 multiplied by what is the power that you are getting, my dear students? 6.187 into what? What is that power that you are getting? 10 to the power? 10 to the power? Just check it out. Minus 7. Is that so? Minus 7. So it will be 6187 10 to the power minus 10 meters, which is 6187 Armstrong. 6187 Armstrong. Just check it out. Yeah. Very good. Awesome. So we will see where is 6187 Armstrong. 6187 Armstrong is orange, guys. This one. Do you see? Orange color is basically that range that we are looking for. So definitely this color of light is orange in color. This is orange colored light. So that is the answer. Very good. Awesome. Awesome. So this particular answer will definitely be orange. This will be definitely be orange. And when you found out this particular answer, this answer came out as 6.4 mega ohm. This was 6.4 mega ohm. Great. Then we have some more questions. Which color will not give photoelectric effect for that particular cathode? Out of all these colors that you have, one of the colors or more of the colors will not give probably photoelectric effect, because see, once you find that orange color is what is used now, so the question now says which color may not give photoelectric effect. Think about it. Think about it. Orange is giving photoelectric effect. If you go to red color has more wavelength. If you see from orange to red, what will happen? Red will have more wavelength, or basically less energy. If it has less energy, then there is a good chance that there is a good chance that the energy of that photon may not be more than work function. Only then it will occur photoelectric effect. If it is less, then the photoelectric effect will not occur. So the photoelectric effect may not occur because the wavelength is more and the energy is less than the work function. So which color may not give? The answer for that is basically red, because only one color is there below orange. Only one color is there before orange. If it was blue, for example, the answer that we got in the previous question, then all these colors will be of lower energy. So green, yellow, orange, red, all these colors may not give photoelectric effect. If the first answer we would have got it as violet, then all these colors may not have given photoelectric effect. If we had got yellow as the answer, then orange and red both may not have given photoelectric effect. Is this clear, everyone? Everybody with me? Everybody with me? Awesome, awesome. So beautiful, beautiful question which has been framed. This will definitely suck away a lot of marks if you do not do it properly. When the other light falls on the anode, the ammeter reading is 0 till the jockey is moved from the end P to the middle point. Therefore, the deflection is recorded in the ammeter. What is the maximum kinetic energy of the electron? Okay. So basically for this particular question, what will you do? What will you do? Come on. When the light falls on the anode plate, the ammeter reading is 0 till the jockey is moved from the end P to the middle point of the wire. Now this particular part, this particular question number 4, this part you cannot do because this part is deleted, because it needs the knowledge of potentiometer. This particular part needs the knowledge of potentiometer. This you can't. So we will skip that. That is okay. So I will tell you which part is there in the syllabus, which part is not there in the syllabus. In that first part which we did, right? First question, second question, third question, you only tell me, did potentiometer knowledge come anywhere here or maybe even here? Even when I did this, it was simple resistor series parallel simple Ohm's law circuit, nothing great. So this type of problem can come, guys, and don't get scared or don't think that it will be bonus. Okay, is that clear? Oh, cool. Let's move then. Let's move. Next question, guys. Question 7. Subatomic particles undergo reactions, energy is conserved, but mass is necessarily not conserved. However, particles' mass contributes to the total energy. So when you talk about total energy, it is made of many energies, potential, kinetic, even there is something called as mass energy. So even the mass contributes to the total energy, and it is never that the total energy is conserved. The energy and the mass together, they form the total energy. That total energy is conserved because mass may be destroyed or created, which is what Einstein told in the famous equation E is equal to mc square. E denotes the energy because of its mass. Particle can also have additional energy because of kinetic and interaction with other particles, that means potential. Consider a neutron and it is separated from other particles, that means it's an independent neutron, and now it decays into a proton and an electron. So this particular neutron has decayed into a proton and an electron, and maybe a questionable particle which we do not know as of now. A questionable particle which we do not know as of now. Whatever is the value over here and here, that also we do not know. Okay. The given table summarizes some of the data from that decay. Electron volt is the unit, and the rest mass of the particle times speed square, that is the mass energy is given. Kinetic energy is also given. Okay, so let's understand what exactly has happened here, and based on that there is a question over here from the given table. Which properties can you calculate? What can you conclude about the third particle? Also another question is this reaction, is it possible? How much mass will be converted if you need a power of this much watts in 1 hour, and what's the equivalent energy of 1 gram of substance? These are all the questions which have been asked over here. So let's have a look at it. Can I have dihydrogen monoxide? Oh my God, dihydrogen monoxide, very dangerous, like carbon monoxide, right? So dihydrogen monoxide, very dangerous. H2O it is. Yeah, but there is lot of dihydrogen monoxide around us. In fact, it is there at your homes, it is there in your bathroom, everywhere. So be very careful whenever you are handling dihydrogen monoxide. Okay, so definitely you can have flare, but be careful. Hmm. Okay, I hope you understood the sarcasm there. Okay, come on, guys. I'll explain you the question. There was a neutron. Imagine there was a neutron. This was at rest. Okay, this was at rest. What happens? It breaks into multiple particles. One is a proton, another is an electron. So the proton will go one way, the electron will go other way. The electron has this much energy, kinetic energy, because it is in motion. The proton has this much energy because it is in motion. And the mass of the proton, mass of the electron are also there. Obviously, that energy consideration should be done. The question is now, what might be the third particle's energy and stuff like that. Okay, did you understand what is happening? Okay, additionally, there is one questionable particle. Additionally, there is one questionable particle. This is what is happening. So let's solve the questions. From the table, which property of the third particle can you calculate? Which property of the third particle can you calculate? Total energy but not kinetic, kinetic but not total, both, or neither total nor kinetic? What do you think is the answer? Okay, come on, come on, come on, come on, come on, come on. Ayo, hey, you didn't understand my sarcasm, flair. What is this? Ayo. Yeah. Which of the following can you not calculate? Okay, think about it. I think we will be able to calculate the total energy, because if I know what was the original energy and this much energy is there on the reactant side, so what is the total energy of that remaining particle? I can find it because I do not know the mass of the third particle. So I cannot find the mass energy. If I can't find the mass energy, I can't find the kinetic energy. But what I can find 100% is this total energy. That this will be the total energy of that third particle. I can't find them individually, but definitely I can find out the total energy, but I can't find the kinetic energy. So not the kinetic energy, total energy, that is option number A. No, it is not C option, it is not B option. It is not C option, it is not B option. How much is the kinetic energy? We do not know, because how much is the mass of that particle? How do you find that out? Because here proton's mass, multiplied by c square, you can do it. Electron's mass, you can find this energy. What is that third particle? Do you know the mass? No. Can you find the mass? No, because mass is not necessarily conserved. So you cannot say, sir, I know neutron's mass, proton's mass, electron's mass, so I can find the other particle's mass. You can't do that. That is the reason why you can't find this. If you can't find this, you can't find this also. But you can find the addition of both of them. Is this now clear? Okay. Now let's move to the second part of the question. Assuming the table contains no major errors, what can we conclude about the third particle? What can we conclude about the third particle? Okay, so I think some values are given. I'll tell you what, from this particular table, okay, just do one thing. Just do one thing. Just add these two together. Just add these two together and tell me how much energy does the proton have. 939.67 plus 0.01. So that will be 939.68. 939.68. Everybody with me? This is the total energy of the proton that is there. I'm just adding these two. Similarly, just add these two and tell me how much energy does the electron have. And similarly, just add these two. It was at rest, so no kinetic energy. So the total energy which the neutron had was 940.97. So what is the electron's energy, guys? Come on, find it out. Yes, find out. Yes, 939.68, correct. What is the electron's energy? 0.51 plus 39. 0.51 plus 0.39. Come on, guys. How much will it be? This is nothing but 0.5 plus 0.4. So that is 0.9. Is that 0.9, guys? 0.9 over here. Very good. This is there on the left hand side. This is there on the right hand side. Now do one thing. These two together, you just add them. Just add these two and tell me what is the result. What is the answer for these two? Come on, just add these two and tell me what is it that you are getting. Yep, just these two together. 0.9 and that 939.68. Yeah, how much is it? 940. Yep, 940 point how much? How much are you getting? 940 point. Yeah, very good. Now compare these two. Compare these two. 940.97 and 940.58. What do you think that difference gives me? What do you think? This guy is the initial energy. This is basically the energy of the electron and proton. So there is some missing energy. So there is some missing energy. So that questionable energy, that questionable particle which is there, how much energy will it have? Think about it. 940.97 minus 940.58. 0.58. Do you see that? That questionable particle which is there, that will have the difference of these two energy. Is that right? Is that right? Everybody with me? Yes. How much is it going to be? How much is it going to be? 0.3, 0.39. Yes, 0.39 is it? Just check it out. Yes, 0.39 mega electron volt. Now this 0.39 mega electron volt is the total energy. Total sum of it will be in the mass, some of it could be the kinetic energy. So mass energy will be definitely less than 0.39, and also similarly the kinetic energy may also be less than 0.39. Maximum can be 0.39. So if you look at the options over here, if you look at the options, it is, what can we conclude about the mass energy? This is the mass energy of the undetected particle. What is the mass energy? Is it exactly 0.39 or it could be less than that? We do not know. It could be less than that, right? So it is definitely less than that, but we can't be more precise. It is definitely less than 0.39 is approximately 0.4. So it is definitely less than that, but we do not know. We do not know the exact value. Is that absolutely clear? No, do not say B option, because the m into c square plus kinetic energy is 0.39. So the maximum value of this guy can be 0.39. Maximum value can be 0.39. Is this now clear? Yeah. Okay. Okay. Yes. Not 0.79. This is 0.79. That 0.79 doesn't make sense. That is another number. This should not have been 0.40. Actually, this should have been 0.39. Okay, so I think there is some small printing mistake. It should have been 0.39 because here they have used 0.39. So this should also have been 0.39. Yes, should be less than or equal to 0.39 mega electron volt. But we do not know which is what. We do not know which one is what. Yeah. So they have said that they have very little errors. I think somewhere they have said that. Somewhere they have said that. Yeah. The given table, some electron volt is a unit, shows the rest mass of the speed of light. Consider the thing and it blah blah blah. Okay. And this table has very little errors. Okay. Cool. That is done. Great. What about this? Is this possible? Can proton convert back into neutron and some other particles? What do you think about this? Can proton convert back into? No, this is not from radioactive decay. This is from binding energy mass defect. So if somebody is again telling, sir, this can't come, think again carefully. Even in JEE, radioactivity is deleted, but they have asked questions on nuclear reaction. Nuclear reaction is not deleted. Binding energy is not deleted. Alpha to, what do you say? Neutrino, anti-neutrino concept, neutron into proton, proton into neutron. These concepts are not deleted. So don't make your own assumptions, guys. Please don't make your own assumptions like that. Then you will face a lot of difficulty. Yeah, is this possible? Yes, I think proton has less mass, neutron has more mass. So mass is more, proton has less mass. So the energy mass wise is less, energy mass wise is more. So other particles will also have some more energy. These other particles will also have some more energy. So if the proton's mass is less, to balance the total energy, there must be some another form of energy, which the proton should have. Are you able to understand? Right hand side, neutron has more mass, other particles will also have some energy. So to balance it out, because proton has less mass, it must have some additional form of energy. So yes, it is possible if it has some extra energy. Yes, it is possible if the proton has some extra energy. Okay, so only then. No is not the answer. Yes is the answer. No, it is not no. It is definitely possible. Okay, many students have got it wrong. See guys, that's how these situations are. Moving to the next question. Mass that has to be converted to produce this much power in 1 hour. So the logic for that is power is the total energy per unit time. Energy is the mass destroyed into c square per unit time. And then this time is there as it is. The question was on mass. So mass will be power into time by c square. So therefore, the mass will be, power is given 500 mega. So 500 into 10 to the power 6 into time, which is 1 hour, which is 3600 seconds, and c square, which is 3 into 10 to the power 8. So that will give you the mass. Just check it out, calculate how much are you getting it. Yeah. Last few questions are there. After this, we'll break for lunch and the session will be done. Last few questions will be there now. Yeah. How much are you getting, guys? 36 by 3, 12, 12 5 is 60. So just check it out. 3600 seconds. How much mass has to be converted? Oh, this is also have to be squared. This is c squared. Yeah. So 3 square is 9. 36 by 9 is 4. 4 5 are 20. So answer will be 2 into something. Just check if it is option A. Yeah. Just check it is option A. I didn't even solve it. In this, what I've done, I've just taken the numerical values. 5 is there. Then you have 36 and 3 square is 9. 9 goes with 36 4 times. 4 into 5 will give you 20. So some powers of 10 will be there. That's okay. Answer will be some 2 into 10 to the power something. I don't care about the powers. So directly I saw the numerical values 3, 4, 1. 2 is there only here. So I directly have marked A. I didn't even think about it. Equivalent energy of 1 gram of substance. This answer. Just use MC square formula. 1 gram is minus 3 kg. 10 to the power minus 3 kg. C square, which is 3 into 10 to the power 8. But obviously square it. 3 square is 9. 10 to the power minus 3. 10 to the power plus 16. Yes, what is it going to be? 9 into 10 to the power 13, which is again option A. Yes, this is just going to be 9 into 10 to the power 13 joules. Yes, very good. Option A again. Very good. Awesome. Awesome. Excellent. Okay. Now, yep, let's go to question number 8. Let's go to question number 8. In this particular question, magnetic field versus distance is given. Now the graphs are not drawn that well. I will, if you want, I will redraw the graph properly. It could have been drawn much better. So this is basically magnetic field. This is distance. For a wire with constant current is shown as functions of radius. The magnetic field inside and outside the wires are uniformly distributed across the cross section. The overlapping parts are indicated by double labels. So rather I will show it to you properly over here. Graph A, oops, graph A is going till here, okay, and graph B is going till here. Then graph C is probably going till here, and graph D is just going till here somewhere. That's all. Yeah, like this. Okay, and now you can start drawing the rest of the things. It is like this, and C and yeah, this is also, it is going till here, and then it is overlapping. Okay, and then over here it is overlapping like this, and this is overlapping. This is the actual diagram. So now you will not face any difficulty. This is the D graph, the green one. This is C graph. No, sorry, this is B graph, the orange one. The light blue one is the C graph. C graph, and the yellow one is basically the A graph. Now, if you remember, there is a direct formula for magnetic field inside versus outside. Inside a wire, inside it is mu naught I divided by 2 pi r square. Actually, that is the radius square into r. It is linearly proportional to r. This is inside, as you can see. Whereas outside, the magnetic field is mu naught I by 2 pi r. So it becomes inversely related to r when you are outside. So that is why the graph is curved. So this is what it is. And everywhere, the graph will basically go till the radius. Yes, all these points are going till the radius of that particular wire. So that wire will be probably something like this, having some radius r, and the current is uniformly distributed across that cross section. So the current is uniformly distributed across that particular cross section. So that is what is basically happening. So current is distributed like this over that cross section. Okay, so this is the theory in this particular case study. Now there are some questions on this. Let's have a look at the questions. What are the questions? Which wire has maximum magnitude of the field on the surface? Which of the following has compare the current density in A and C? Which wire has more radius? Okay. Lastly, what is the direction of the flow along the length, or sorry, a direct current flows along a long wire which is basically thin walled, then what is the magnetic field inside of it? Okay, so all these are the questions. First question, which wire has maximum magnetic field on the surface? That you can directly see. See, you can look at the graphs. This is on the surface, this is maximum value, this is maximum value, and whatever is this is basically the radius, which is basically your surface, So which of them has the maximum field on the surface? You have to check the peak values. So A has the maximum field. So the answer for that will be obviously A. Everybody? No, it is not C. It is obviously option A. Yeah, it is obviously option A. Okay, not C or anything, it is A. You have to check the highest value because the graph first goes linearly up, then goes down. This is exactly on the surface. You get the maximum value. Okay. Next question. Compare the current density. Now, how do you compare the current density? Well, the formula which you have over here, I can rewrite it. Magnetic field inside is mu naught by 2, and then you have current by pi r square, into r. This one is the current density. This one is the current density. So take that over here. B in, or rather just keep it like this, mu naught by 2. This is current density multiplied by r. Okay. So for a given r, I can do one thing. Just put this r as the radius. This will come on the surface, whatever is the magnetic field on the surface. So just put small r as capital R. I'll get the magnetic field on the surface. So the magnetic field on the surface is mu naught by 2 J, and this is R. Oh, but R is also going to be different. So we can't do that as well. I think there is only one option now. Let me differentiate both sides. So the magnetic field with respect to R, if I differentiate it, mu naught by 2 current density dr by dr. dr by dr is 1. So it will be mu naught by 2 into J. This dB by dr is nothing but slope of the magnetic field versus the distance. So if I want between A and C, who has more current density, the one which has more J will have more slope. Higher slope, higher J. So let's go over here. Out of all these graphs, graph A has the highest slope, even B has the highest slope inside. But if you compare it with C, C's slope is lesser than A's slope. So definitely you can see over here, slope of A is more than the slope of C. The slope of C, you can watch it here. A has a higher slope. C, the blue one, has a lower slope. So therefore, the current density will be higher for A. So the current density will be higher for A. Is that clear? What a brilliant, brilliant question. Which of the wire has the greatest radius? So to find that greatest radius, very straightforward, guys. Just look at all the graphs. See which graph ends the latest, which graph ends the last at the highest point. I think it is this graph. As you can see, this is the surface point. This is the surface. So the surface is the farthest for graph C, I believe. So hence the answer for that will be C. Will be C. Can you see that? Awesome, awesome, awesome. If you take a long wire, thin walled, then what is the current? Sorry, what is the field inside? This is direct, guys. If you have a thin walled current carrying conducting wire, carrying current in that particular wire, always inside this, the magnetic field is going to be 0. The magnetic field is going to be 0. The magnetic field will only be present outside. Yes, the magnetic field will be only outside. This is by Ampere's law. This is also there in your NCERT. So the correct answer for this will be 0. So if you have a long wire, thin walled cylindrical wire, current is flowing, then the field inside is obviously going to be 0. Is this clear? Wow. So those are the answers, guys. Shall we now do assertion reason questions really quick? Ready for rapid fire mode? Ready for rapid fire mode? Yeah. If you go outside, then what is the field, you might ask? If you go outside, then the field is just like a normal wire. The field is just like a normal wire. The field outside is mu naught current by 2 pi r. This is outside. Okay. And it is definitely not 0. Just like a normal wire carrying current. Yeah. Inside it is 0 because current inside is 0. So that's the reason. Okay, show some energy, guys. It's been a long time. Yeah, let's go. Let's go, let's go, let's go. Okay, great. Rapid fire now. I want everybody to be on the rapid fire mode. Okay. So here comes the first question. The process of photoelectric emission, all electrons do not have same energy. If the radiation falling on the photosensitive surface consists of different wavelengths, energy acquired by the electrons absorbing the photons of different wavelengths will also be different. Is this correct explanation? Is the reason correct? Is the assertion correct? Yes, the electrons which are emitted, so it is like this: HF is equal to work function plus kinetic energy plus the energy lost in the collisions. So if you talk about the maximum energy, it will be K max, and the electron which did not collide will have the maximum kinetic energy. So definitely the kinetic energy is less than K max or equal to K max and can be having a range. It can have a range, and that range is because of the collisions. So they do not have the same kinetic energy. Assertion is wrong. If there is light of different wavelengths, so hc by lambda, so if there is different wavelengths, then what will happen is that the kinetic energies will be different, maximum kinetic energies will be different, but this is not the reason for that. Yes, if radiation falling is of different wavelengths, then the energy acquired by the electrons depends on that wavelength, definitely. But this explanation of the range is not different wavelength. Even with one wavelength, you will get different kinetic energies. Even with one wavelength, you will get different energies because the electrons may collide within themselves and lose some energy. So the reasoning is correct. Whatever the reason is saying, that statement independently is correct, but it is not the correct explanation. So B is the correct answer. Many students would have got it wrong. Yes, B is the correct answer. Check it out. Okay. So the correct reason for the first statement is when the electrons are ejected from the surface, they might collide with the atoms and lose some energy. So some electrons will lose more energy, some will lose less. That's why they have different energies. It's not because of different wavelengths. Clear? Everybody with me? Shall we go ahead to the next question coming up on your screen? Yep. Everybody? Okay. So if you take a hydrogen atom, there is only one electron, but the emission spectrum shows many lines. If you take a sample of hydrogen, there are many atoms with the single electron, but every atom may be having the electrons in different orbits. So the transitions which are possible are many in number. Is that correct? What do you think? So maybe there is one hydrogen atom like this, another hydrogen atom like this, another hydrogen atom like this, another hydrogen atom like this. So everywhere the transitions, there is one electron only, but that electron might be going here, this electron might be going here, this electron might be just going here, this electron might be coming from somewhere else and then coming over here. So every time there is one electron, but there are many hydrogen atoms. Each time the transition happens, there is a wavelength which is emitted of different value, Yes, different value. So there is different wavelengths even though the element is same, because the number of atoms are too many. Each atom might have different transitions. So yes, assertion is correct, but the emission spectrum shows many lines, and each atom, even though it has single electron, different atoms may have different transitions. So the reasoning is also correct, and it is explaining it also properly. Yeah, very good. Awesome. Awesome. Sir, room is very dark. Whose room, Nitesh? My room or your room? If your room is dark, then there is a switch. Just turn on that light. If my room is dark, it is my choice because I want you to see the board properly. Okay, assertion and reason both are correct, and explanation is also correct. If the distance between parallel plates of a capacitor is half, dielectric constant is made 3 times, capacitance becomes 6 times. capacitance does not depend on the nature of the material of the plates of the capacitor. What do you think? What do you think is the correct answer for this particular question? Hmm. Nitesh, you can also do one thing. If the room is very dark, you can perform Young's double slit experiment. That will be very beneficial for you. Perform. Tell me the results. What you get. Find the wavelength. Yeah. Sir, but in a dark room, where do I get the light from? Arey, you are a very bright student, right? So if you are a very bright student, you will be emitting some light source. And if you are long, you will be like a cylindrical source. So you can assume yourself as S and then take a cardboard sheet and make two slits. And on the wall of your dark room, you will see an interference pattern. From that, you will be able to find your wavelength. Yeah, because you are a bright student, so you will have your own wavelength, correct? Okay. So what do you think about this? Yeah, capacitance is epsilon naught A K by D. What have you done? The distance is halved. So this is made half times. Dielectric constant is made 3 times. So 2 goes on the top and multiplies with 3 and it will become 6 times. Perfect. Assertion is correct. Capacitance does not depend on the material. Correct. How does the material of the plate depend? Material between the plates matters. So this K that you talk about is the material between the plates, not material of the plates. Plates are always conductors. The size will matter. Is that absolutely clear? Yo, Nitesh, don't worry. I'm not getting offended, bacha. I'm just taking it very lightly. Yeah, my board brightness is less. No, the mm, reason why I have probably kept it like that dark is basically so that you can see things clearly. If I make it bright, what happens? These lights and that walls which are there, they start reflecting. So the contrast goes away. Okay, so that's the reason of why you might probably find a little bit darkness. But otherwise, there is a deliberate reason why I have kept it little dark. Maybe this is not very bright, the alphabets. Yeah. Is this the reason correct? But it is explaining it? No. So option B will be correct. Yes, option B. Very good. Very good. Excellent. Excellent. Awesome. Moving on, next question. There is an electric lamp in series with a solenoid copper air core and then connected to AC source. If a soft iron is inserted in the solenoid, the lamp will become dim. Ooh. So you take a AC source and you take a solenoid and then take a bulb. This is your bulb. This is your solenoid. Okay. And what is asked is you are placing an iron rod inside. You place an iron rod inside. So the moment you place an iron rod inside, what will happen? It is a ferromagnetic material. Iron is a ferromagnetic material. So the inductance will go up. So XL, inductive reactance is omega L. So inductive reactance will also increase. So because of this, I feel the impedance Z will also increase. So the current I will decrease. So the brightness, of that bulb will also decrease because current reduces. The automatic effect will be the brightness will reduce. XL is not decreases, XL is increasing. XL is omega L. When did I say XL is decreasing? Okay. So the lamp will become dim. Is this correct? Definitely it is correct. Definitely it is correct. Yes. If the iron rod is inserted, the inductance increases. Is this correct? Yes. Because the inductance increases, the impedance increases, and that's why the current decreases. Is this logical flow correct? Because of the inductance increasing, the current has decreased and the brightness has decreased. Yes. So it is the correct explanation also. So it is A. Okay. Very good. Awesome. Is this absolutely clear? Very nice. Very nice. Yes. Option A, guys. You can see it. It is correct. Next question coming up on your screen. Here it is. Photosensitivity is very high if the work function is very small. Work function is h nu naught, where nu naught is the threshold frequency. What do you think is the correct answer? Okay. So photosensitivity of a metal is high if the work function is very small. If work function is small, that means you need very less energy for plucking out those electrons. So easily it will emit electrons for any random light. So it is more sensitive. So yes, it is correct, because less work function means less energy to pluck it out. So easily light will be light of less energy can light of even small energy can give photoelectric effect. Photoelectric effect. So yes, it is more photosensitive. Work function is h nu naught, where nu naught is the threshold frequency. This is also correct. And does it explain this? Yes, because oh no, wait, is it explaining it? No, how is it explaining it? If work function is small, it is more photosensitive. No, not exactly. Not exactly, guys. It is not exactly explaining it. It is option B. So just because work function is h nu naught, how is it telling it is more photosensitive? Is it telling us? No. Work function is h nu naught. So it will emit light, photoelectrons for every single wavelength of light, because more chances of photoelectric effect occurring. I don't think it is explaining properly. No, it is not the correct answer, explanation. So yes, both are correct, but it is not the explanation. B option. Is that clear? Okay. Kai, it is based on PYQs and plus our own question bank. Yeah, from our own question bank, and some are also PYQ based on the trends and the patterns. Okay, that's how CYQ is based. Is that okay, Kai? All right. Next. Come on, my dear students. Come on, my dear students. Yes, when ultraviolet light is incident on a cell, the stopping potential and the maximum energy is Kmax. When ultraviolet light is replaced by X-rays, both of them will increase. Photoelectrons are emitted with speeds ranging from 0 to maximum value because of the range of frequencies present in the incident light. This is very interesting, guys. Many students can make many mistakes over here. Okay. I have a feeling the reasoning is only wrong. When I read it only, it felt wrong. See, you get a range of kinetic energies, range of speeds. Is it because of range of the frequencies? No. This is because of collisions. Collisions energy which is lost, that is what which causes the range. So reasoning is wrong. Wrong statement. Reason is wrong. Reason is definitely wrong. Okay, you get different electrons with different speeds, because some electron will come without colliding, some electron will collide many times. It's not because wavelengths are different. No, single wavelength monochromatic light can also give, yes, can also give different range of kinetic energies. So what about the first, ultraviolet light? If you go to X-rays, X-rays has more energy. X-rays has more energy than ultraviolet light. So what do you think will happen? Both stopping potential and Kmax increases. So energy of that photon is work function plus Kmax. So obviously, if the photon's energy increases, Kmax increases, and Kmax is E into stopping potential. So stopping potential also increases. So this statement is correct. So assertion is correct, but reasoning is wrong. C option. Just check it out. Yes, C option is the correct answer. Everyone clear? Very good. Awesomeness. Awesomeness. This is not dual nature. This is photoelectric effect photons. Okay, but that chapter, yeah, similar chapter. Okay, what is the next question, guys? Let's see, have a look at it. Capacitor is filled with a slab, which is with a metallic slab. Its capacity becomes large. Dielectric constant for metal is 0. Oh, this is very straightforward, guys. Yep. Usually, what we have found is many times assertion reasons are asked from modern physics and electrostatics, capacitance, potential. That's the reason why we have put those questions more. Is that okay? Chances are there. I'm not saying it will come only from that. Chances are higher. That's why I'm making you practice these questions more. Okay. Now, when you put it with a metallic slab, just see capacitance is epsilon naught Ka by D. Actually, for a metal, K is infinity. So it is not 0. So the reasoning itself is wrong. Yes, the reasoning itself is wrong. Yep. And it becomes very large capacity because K becomes infinity. So capacitance will also become large. Hence, C option is correct. Is this clear? Is this clear? Very good. Very good. Awesome, guys. Moving on to the next question. Faraday's law come as a consequence of energy conservation. In a purely AC circuit, current is behind the current is behind the EMF. What do you think about it? Come on, come on, come on, come on. Lunch, I know. Just few more questions, I think, and we are done. And we are done. Faraday comes because of conservation of energy. I don't think so, guys. Is it because of conservation of energy only? Are you sure? Or is it Lenz's law? Okay, we'll figure it out. AC circuit, in a purely resistive circuit, the current is behind. No, current is in phase. The current is in phase. It does not lag. Current is in phase. So reasoning is definitely wrong. A resistive AC circuit, current is in phase. So this is wrong. Faraday's law comes because of conservation of energy. I think Faraday's law, well, Lenz's law for sure. Now, Faraday's law says that when you change the flux, then there is EMF produced. So what happens is when you change the flux, there is EMF produced. EMF is basically your electrical form of energy. And when you are changing the flux, you are either moving the magnet, or basically you are moving the coil, or you are somehow increasing the turns or rotating the coil. So what does that involve? That process definitely involves mechanical energy. Mechanical energy. So indirectly, the mechanical energy gets converted into electrical energy. And we can see that is why the change in the flux causes the EMF. So yes, assertion is correct. So it should be option C. It should be option C. Yes, it is the correct answer. Everybody clear? C for your capto. Yeah. Okay. So that's it from today's session. And we had a wonderful discussion. We have solved some 8 case studies, which took a lot of time. We have done it properly in detail. And I have told you how case studies can also explore some tits and bits of outside the syllabus without you having to know the exact concept. They will check how you are able to apply on the spot. Most of the times the answers are in the passage, or you have to use the knowledge within the passage plus the extra knowledge which you have learned in NCERT. Okay, so properly read the passage. Most of the times it is not that difficult if you understand the concept, and do not get confused by the complex jargons or extreme terminologies that they might use to confuse you. Chumma, they will scare you, but then when you actually solve the questions, they will be laddu. Sometimes when the passage is simple, the questions can be actually very lengthy to solve or very calculative to solve. So that is what I have usually seen, but we never know what might happen. Okay, so today evening we'll meet again for graphs and numericals. All are excited for graphs and numericals? Yes, the session will be there on the channel. Okay, yeah, if you have forgotten to smash that like button, please do that. Yeah, this is your numericals and graphs question series, and of course this particular session, do not forget to leave a comment below and smash this like button as well. Okay, thank you so much, guys. Thank you for subscribing, thank you for liking, and I need your likes because it shows your love and affection towards this channel and the efforts that we are putting in. Bye bye, take care, have a great time.